Well, that's interesting. Virtual is not allowed. Let's see. Probably something I forgot to do. Signature virus. That doesn't help at all. Oh, damn. That's right, you have to do a typed in. Well, no. Oh yeah, I can't have a constructor. That's why. MSDR. Alright, so that's the problem there. It's a constructor. Constructors can't be virtual, so I done fracked up. Alright, so let's say no constructor. Constructor. Alright, so what else do we need for this though? I started to do something here, then I was like, okay, we need resources. Interesting. Shouldn't these have a certain, yeah, see, it should be like this. That's really weird. Oh, there we go. That was the problem. I gotta say, what happened to all the frickin' what happened to the color coding? Well, the error right there killed it. That is interesting. So, res list. Now I have to consider. I probably have to also do something for demand. Let's see, demand and supply. So that's going to have to be... So the demand will have to be the ID of the item, and then how many units of that item are being demanded, how many of them are wanting to be bought. The supply will have to be the ID of the item and how many of the item are available. So really we could use one struct for both. We just gotta figure out how to name it. Well, we could have it be like a struct, and then yeah, I guess we could. I guess that's how we'll have to do. We'll something like a struct that'll be like it'll have to be called like item total or something like that. I don't know. Something that'll just be describing the fact that it's an item and the number of items that they have. Well, hell, we can just call it item. Why not? God, that was simple. Call it an item, because it is an item. And we're not using the item file anymore, because we're taken out a hell of a long time ago. In this case, it's going to be a struct, so we're not going to make a traditional thing for it. It's just called an item. It's going to be like the data placeholder class. Yeah, we don't have to use strings or anything, just go straight for it. If and def item define item struct item int I ID int I num. So item ID and number of items. Just like that. And they got two ends. Alright. So back over to eNode. Also want to include... Damn it. Keep on hitting the $sign. Been working with a lot of PHP recently, so it's just kind of like, okay, I'm going to add a $sign to do something. Like a dumbass. Alright, so item. So vector item. So we're going to say supply list. So before we can figure out what all values, rather functions we need, we have to figure out the variables in use. So we got the res list, resource list, resources that the node has for its use, the items that are currently able to be supplied for demand, and then the amount of demand. So essentially, the supply list has two functions. One, it's used to compare against the demand to determine if there is lower supply than demand to initiate a buy for that item. While the supply is used by other nodes to see what items this node has for sale. And so that kind of will work with the demand list, and it kind of creates a supply and demand structure for the entire system of nodes. So we have the resource list, supply list, demand list. What else do we need? Maybe some variables that determine frequency of trading, or the maybe, because we have to also take into consideration that the AI is not always going to be buying things won't be buying things for the highest price, or the lowest price, or the highest price. It's going to look for the lowest price. However, there's going to be other constraints on that. So, what kinds of things would we be looking at? So we want to limit the number of nodes that it can look for. So let's say that it can only, let's see, int. We'll say, so the number of nodes now, how would we describe this? Essentially, this is going to be the limit to how many nodes away it can go, but that's not how I want to describe it. In other words, if there's a better deal at a node that is not directly connected, but connected through from... so, let's say you have the node... Let's go and do some pictograph style explanations here. Or is it called pictograph? What is that game called? I forget. Pictionary. Style stuff here. Let's kind of explain this. Because this, really we need a visual aid to explain this. You're going to get to witness my crappy drawing skills here. I guess we'll just do with that, it's fine. So let's say that we have some nodes. And we'll do them in alright, so we got this, then we want to do let's see, wait. Oh, crap. So let's pretend this is outer space here. That's why I'm putting the stars in here. And of course we did a little screw up trying to click too fast through here. I really should have gone with a freaking smaller thing. Damn it. It's so easy to do more than one of these things. Alright, so say this is outer space here. Alright, and we have some, let's say that each of these stars that I'm going to be circling here is going to be a node. And we're going to circle them with light blue or something that's going to show up really well here. Ellipse, and I just want to do a kind of hollowed out thing here. So let's say we have a node here. Oh my god, okay, this is when Photoshop gets so damned annoying. Alright, so let's go to styles with this style. So it's there, it's just not showing up. What the hell? I bet it's because the stroke is black, huh? Yeah. I'm gonna do a stroke, but have it be the color that it's... Damn it. Stroke, yeah, that's the problem here. The color, I want that color. Alright, problem solved. There we go, yeah, so that's where we went. Except that's not quite the kind of node we're talking about here. Damn it. Alright, there we go. Get rid of all this stuff here. Okay, now that we're done screwing on with Photoshop's inadequacies here. So each of these represents a different trading node in our trading node network. We'll say each star represents a system. Each circled star. We'll say the uncircled stars are represent systems that are not inhabited or don't have trade routes or whatever. So let's say that the system that we're going to be trading from will be circled in red. Now let's say green for it being our system. Chime of doom. So let's say we're here. You are here. You can make an arrow saying that, but so this is where we're at. We're trading the current node that we're observing is this node here, and we're watching how it trades. So let's say that these are all. Let's hook these together next. Now we have to kind of describe how the nodes will be hooked together. Damn, we'll have to do that too. Node connections. That'll have to be something we'll have to consider. Go to line. Do another, and the line color will be I'll make the line colors red. Alright, so where were we before we were so rudely interrupted? That's right, we're over here trying to make sense of this damn thing. Alright, so just pretend that, what the hell? Okay, that's, I don't know, that's just freaking weird. What the hell? Line tool, line. Alright, what the hell's going on here? That is just too... What the... I don't understand this. Let's see. What is causing this? Well, hell. must be some setting somewhere that's causing it then. God, what is... I don't know. So fractal. What in the H is going on? Let's try line tool not working. Reset tool. Well, that's interesting. I want to make a freaking line. I don't want to make a... There we go. Oh, I see it's in inches. Damn. Wait. That's too much. Let's go 10. Still too much. I guess I'll do so. Let's say this represents trading lanes here. Not in the traditional sense of what I was explaining in the video before, of how these work, but just as an example of what nodes hook up to which nodes. Oops. So let's just say that a random way of connecting up nodes to each other creates something like this. So a node can only trade with another node that's connected to. So this node, for example, cannot directly trade with any of these nodes here, or this node. It has to trade through another node. So in other words, it has to jump. The node has to travel. The trade has to travel through this node to this node, or through these nodes to get these nodes here to get to any of these. Now, what I was suggesting over here was, and why we need to explain this to explain it is because it's kind of hard to explain with words. So this NJ restrict is node jump restrict, essentially what it stands for. And what its focus or its objective is going to be is to limit the number of nodes away that one node can trade with another node. So let's say that the NJ restrict value for our current node is 5. So that means that any node that's connected to it within 5 jumps, a jump being going from a node it's connected to a node that node is connected to, and so on and so forth. So for 5 nodes, anything within 5 nodes can be traded with. Anything outside of that 5 nodes cannot be traded with. So for example, 1, 2, 3, let's see, 1, 2, 3, 4, 5, well let's see, 1, 2, well these are all within 5 though, aren't they? So let's say 3 then. So 1, 2, 3. So any node past this node, in other words these 3 nodes, this node cannot trade with them. So it can't trade with this node, cannot trade with this node, none of these 3. It can with this one, it can with this one, it can with that one. Oh, right, it can with this one. So let's see, so 1, 2, 2, 3. So the only nodes that it cannot trade with are these 3 here, if this is restricted to 3 drums. Now let's say that the current node is down here on this one. Let's say it's restricted to 3 drums, or let's say 4 drums. So 1, 2, 3, 4. So it cannot trade with any of these nodes here. 1, 2, 3, 4. 1, 2, 3, 4. So it cannot trade. Let's see, 1, 2, 3, 4. And it cannot trade with this node or with these 2 nodes, but all the other nodes. So essentially this node can only trade with these nodes here if it can only trade with nodes that are 4 jumps or less away. So this is a way to kind of create a to segment off a node collection, if you will, or a node grouping, so that every node within the group isn't able to trade with every other node in that same group. So essentially what we've done is we've by selecting these off into a certain number of range that it can trade in, we've created a region. So for example, this node's region is, let's get the free line tool here, or pencil I guess then. So in this example, the region of this node here is essentially this. Well, let's actually make that a lot smaller. So that's the region for this node here. Actually, let's go ahead and actually do that. So this node, this region. Alright, take that off. Change this to another color. Now let's say that this node here has a, let's do this one. And it's got a 3 jump region, I believe we said. 3. So its region includes everything except for those 3 up here. So now let's say that this node here has a 1 jump region, so it can only trade with things that are within 1 jump of itself. So that means this one, this node, this node, this node, these 2 nodes. Everything else it can't trade with. So just these ones here. And this is essentially what we're creating is going to be like a node or a regional trade kind of diagram or whatnot. Something that will just show you which regions are able to trade, what the regions are and what nodes are able to trade with which nodes. And let's say that this node here has a 5 node jump restriction. So within 5 jumps it can trade. So 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it can trade with every node except for these 3 and these 2. So this one, 5 jump region, and its region is this. So now if we show these different regions here, you can kind of get an idea of how this would work. So certain regions can only trade with certain systems can only trade within a certain region, and that region for that system or node is determined by the number of jumps it's limited to. Now this is just for the AI trading. This isn't for the player. The player's trading will depend on their skill levels. So it kind of is, I don't want to say unbalanced or unfair or anything, but it's different for the AI than it is for the player. But what the player can buy will be influenced by what the AI can do itself. So it kind of reconnects to it. I'm actually going to keep this in because it could make a somewhat interesting image for Wikipedia or something, or the wiki, not Wikipedia, but the wiki page, wiki thing for OV. So let's go ahead and save it. So looking at this here, you can see that there are several areas that are kind of overlapping with each other, or a lot of area that is. But as you can see now, none of the circled selected nodes can trade with these 3 nodes. So that's kind of an interesting thing there. So these 3 nodes might be have limited options for trading or something like that, you know. Now it's worthwhile to note that this indicates what which nodes these particular nodes can contact or communicate with for trading. It doesn't mean that nodes that are outside of their region here cannot talk to them. So for example, while these guys can't talk to these 3, one of these 3 might be able to talk to one or more of these guys. But these guys will not be able to initiate the trade. Only these ones will to them, because these guys cannot reach these because of their region restrictions. So that's kind of what that setting is going to be for this. So restricts how many nodes away this node can trade with. Does not keep nodes outside of trade region. So, list of resources available to this node. List of items this node owns. List of items this node wants. Alright, so what other things will we need for this? Oh, and this will also determine how far away they can look for better deals. So, if maybe there's a node that's outside of the restriction range that has a better deal, but this node will not be able to trade with it because the node's outside of its area, trade region. So that's another way to kind of add some enhanced negative pressures on this particular node. We also need to have some random values that will determine how aggressively it's going to be looking for those better deals. So, for example, not have every node, just mindlessly search for the best deal and then get the best deal for the things, but have it so that there are times when the node might make a bad decision or and sell things for higher or sell things for lower or buy things for higher than it can, because within the node there is a better deal, but add a little more variability to the chances if it does or not. So let's call this int. No, let's do a float. Float might be better for this. Float. What should we call it though? Maybe end deal ratio. Okay. What else do we need? Well, we should probably restrict the number of trades it can make at any one time. For example, you don't want a node to be able to trade endlessly. Because that would make it a little unbalanced. You want to be able to trade a certain number of times over a certain amount of time to kind of restrict it a bit. Also, just for the performance sake, you also want to limit it to a number of trades. So int. We'll say t limit, nt limit. Number of trades this node can make per, we'll say turn here, per minute for 1.0. But we'll have to change it to a time-based thing for later versions of it. What else? I think we'll stop here for this, and we'll add more as we need to. So let's go ahead and make the functions now. So we need to have functions that will populate these values, because they're all going to be randomly chosen. They're not going to be done on a hard-coded or supplied value basis. It's all going to be based on randoms. But the random values will be able to be changed. The ranges for the values will be changed. So what we need to do now is, after the constructor is called, we'll need a function that will process all the all these things to make the values. So virtual void. We'll say setup node. Okay. Of course, we'll have to add. Crap, what is that?
Namespace, that's what we're looking for, namespace. Namespace gv gvars equals gvars. We have to add global vars to it. No, that'll be in the whatchamacallit, yeah. The whatever file is going to be having the nodes in them. I guess it'd be the economy that would have it. So we have the virtual void there. Next up would be well, we'd have to be able to get the return what's in the supply list and the demand list, and use those for so we have to be able to look at the demand list and then query any nodes within the node range. So that's another thing that we have to consider, the node range. Well, the node range will correspond to the that is another thing. How to take this. I'll take all this off. How to get this kind of an image in terms of how it's set up in the code. So where you look at one system or one node, and you determine from where that particular node where these ones are at and where the connections are at. So I guess we'll have to do is to say have a vector in each vector element, vector member rather, in each node that has a list of connections, node connections. So for example, in this node, we'll call this node 1. Or let's do this. Let's actually go ahead and give these some sort of title here. Alright, so now we got these labeled up here. So this node is L, and so on this node there'll be a vector that'll have a list of other nodes that are connected to it, and that list will contain J, I, K, and J. So when this node goes to trade, it'll look at that list and say, okay, I can trade with my directly connected points are I, K, and J. And then what it'll do is it'll go to each of these and find and grab from the node lists of those the connecting nodes. So remember, this is a 3 jump node, so it'll go so from J to get to Q, From I we get E and C, and from K we get N and O. And it will, if there are duplicates like for I and K for E, this is an I and K both, it'll just ignore them. We'll have a function that'll remove duplicate nodes from the trade region node list, which we'll put in there too. And so that's 1, 2, and then each of these will also give their own. So, and in fact, what will happen is that, well, let's do this. Let's see. Let's merge all these before I forget. And then merge that with the background here. I should have merged all this stuff together a while ago. Okay, Control E. Okay, yeah. So, in a sense, what would happen is that the node, the trade region vector, would have essentially all these nodes within it. And what it'll have is it'll have the node and then how many jumps away it is. That's an interesting question. Should the number of jumps that a node away is determine anything about the transaction? So, for example, well, I guess it would, because I said in the I don't know if it was a trailer or the no, it was the first round of the developers vlog videos when they were talking about the new menu changes. That the time that a trade would take to complete would depend on how far away the node, wherever it was you were trading with, was from you. So we're going to make the same with the trading system for the AI. So the further the node is, the longer it'll take to the trade to complete. And so yeah, we'll have to also indicate the number of jumps away the node is. So we'll probably have it be like a tuple, if you will. We'll make a struct that'll contain a string for the name of the node, and then an int for the number of jumps away it is from the currently selected node. So in other words, to have an example, J, I, and K would be 1. So J1, I1, K1, E2, N2, O2, Q2, P3, R3, M3, G3, A3, and B4, F4. Or no, I guess it would be 3 and 4. So was it a 4? I guess it was a 4-node jump, this one was. 1, 2... No, I guess 3. No, yeah, 3. 1, 2, 3. So G would be 2, and then F and B would be 3. That's my mistake on that. But just kind of get the idea with that. That's kind of how the thing will set up. So, let's create a vector. Vector of, so call it T node, and call it T region. List of nodes available for trade. With. And we'll have to create the T node struct. Should be T node. Should be pretty quick. So if and def T node H. Define T node. string tn name int tn jumps. And again, tn jumps will be the number of jumps from the current selected node. And if so, we want to also add that here. All right. So we need a couple. So with that now, so what we need to do is we need to be able to get let's see, T node. So virtual void create T region. Then we'll need, let's see, virtual void let's see. Oh, you have to say the type of the vector. Well, that could help. So vector. Aha, cool. I'm actually be able to use that in the code, actual code that we have now, for the data system and database code to drop off some of the passing by references or whatever. We have the passing in a reference of a thing of a vector object and filling up that vector by the reference with data. Just return it itself, return the vector itself. That would be a nice thing to do. It'd help clear. Well, I'll have to see how it works. So equals 0. Return supply list to requesting node. Actually, let's call it send supply. So Alright, so we have to now have also have a reciprocating function for that, which will get the supply from a selected node. So, the question is how do we want to process that? Do you want to say that's going to return a vector as well, or that it's going to, no, you'll have it return a vector as well. And that'll be part of get supply from request supply list from specified node. Alright. So we get the supply list, send the supply list. So I'm going to set up a virtual void. Process deal. For we'll say sales. Now, as part of this, we want to be able to get what the virtual well, let's say int. We'll return the element number. So get h demand.